Thank you, everybody. Audio okay? Okay. So my name is Nick Thompson. I run a company called Creative Intent. I've made a couple of plugins called Temper, Tantrum, and Remnant. I also recently teamed up with the awesome folks at Sing. There are a bunch of us walking around here. Come say hi. So this talk is about Blueprint, and Blueprint is a library that I wrote that enables you to write cross-platform native apps using React.js and JUCE. And I hope a couple of you at least were in here for Tom's talk earlier, because it was a really awesome talk through React Native. This picture here that we're looking at is my latest plugin. It's called Remnant, and the interface is totally written in React, but it is running via JUCE on all major platforms, all major plugin formats. And this was a really exciting milestone for me because I want to make plugins, and React Native doesn't quite, help me with that easily anyways. And so getting here is really exciting, and I'm really excited to share how I did this, and hopefully in these next 20 minutes give you a compelling enough argument to want to take this thing for a spin. So we're going to do a really quick tour here because I only have 20 minutes and there's a lot that I want to say. So what I want to talk about is web technology, and in particular this conversation that I've heard a lot about this idea of whether or not we should consider web technologies for writing our GUIs. And then I'm going to share some kind of counterpoints that I have to that idea and introduce React.js after that and why I think it's a valuable piece of technology, and then introduce Blueprint, how it works, why it's cool, and show you a demo. So in this space, in the past year, I feel like I've been hearing this conversation about like it would be a really good idea if we use HTML, CSS, JavaScript to write our UIs. And I've heard this a bunch recently. I've heard this a bunch over the past few years. And this is just like a short list of technology that I pulled off the top of my head of companies that are trying to do this actively, companies or projects or conversations. And I think Chromium Embedded deserves a little bit of a highlight because for anybody who was at the JUCE panel last year at ADC, there was a conversation about the future of JUCE UIs and what that might look like, and CEF came up as an option moving forward. So I'm curious, like why are we talking about this? Why is it interesting? One argument is that it enables cross-platform development, right? I mean, if you write a web app and you load it up in a browser engines are cross-platform, so then if you embed the browser engine in your application, you get cross-platform for free. That's cool, I get it, but a lot of us use JUCE. JUCE is cross-platform. I'm not too excited. Like, I've got that one. So the other argument, and the more interesting argument, in my opinion, often involves a graph that looks like this. This is a picture from the Stack Overflow developer survey in 2019 showing popular technologies, and web tech is dominating at the top of this graph, right? And you might say, okay, but everybody needs a website these days, and I think that probably accounts for why there's so many web developers, so this is probably a little skewed, right? Maybe, I think there's a little bit more to that story, and in particular, I have this hypothesis that the barrier to entry for working in web programming is lower than that, at least that of C++, right? And that's important for people getting into the industry. So let me break down why I think this is true. It's everywhere. So your browser is your IDE, right? By the time you open a computer, you already have a full development environment for working in web technology. It's helpful. The languages are super forgiving. Like in HTML, if you forget a closing tag, the browser will just put one in for you. Or if you misspell a CSS property, we'll just ignore it and move on to the default. Like, you don't have compiler errors. You don't have like long lists of issues that you have to solve before you can see anything. It's fast. The developer tools in web technology are crazy, and the edit, compile, run cycle is virtually non-existent. And especially for new developers, like because the browser is such a visual environment, you can immediately see what effect your code is having. And then the last bit is that these languages are declarative by nature, and I think that's really important both for people who are new to programming, but also important for the way that we think about building a user interface. So in HTML, I want to put some text inside a blue rectangle. That's all I have to write. I don't care what has to happen between these 3 lines of code and how this gets to the screen, right? And I never have to care, and that's awesome. So these are some good things about web technology, but let's get into some of the gotchas. This is a quick quiz kind of thing. If this is the full HTML document that I give you, quick question, is this valid HTML? Anybody? No. Correct, it is not. What do we do with invalid HTML? We turn it into valid HTML, just kind of for you. I don't know if you wanted those spans to go inside the div, but that's where they ended up. And then the page will just render. OK, CSS. You want to show up and change this brand background to red. OK, so you see some code that looks like this. You change that blue to a red, and then your footer turns red. And that was not what you wanted, so you have to figure out a new approach. How do we solve it? Well, just throw a new class name on there, turn that thing red, and we'll be good, right? Doesn't work. Why not? Maybe I try something like this out of frustration. Is this valid CSS? Yes, it is valid CSS. Did it work? No, we needed that one. That makes sense. How about this? Anybody ever seen a JavaScript function that looks like this? No, why would we write that, right? This is 2019. Let's step it up. So you might write something like this. What's the gotcha here? Well, the gotcha here is that this is ES6. It's pretty new features. Browser rollout isn't quite there, so you'll probably use a transpiler. The transpiler will turn it to this. What's the gotcha here? You touch the arguments object. That means the JIT will not even touch your code. That makes sense. OK. So these things about web technology are hidden gotchas, but they're actually features. They're not bugs. And the reason that they're features, or at least that I'm calling them features, is because at the time that they were introduced, they were solving a real problem. But nowadays, what we've tried to do with the web has outgrown these features, I would argue. And so now there's all this hidden complexity and hidden gotchas in using these technologies. But browser engines can't really change that, because if the HTML spec changes, or if a browser vendor chooses not to support some of this stuff, half of the web just won't render, right? They're not going to do that. But there's some really good things going on here. So I'm kind of interested in web technologies. And I think what I want to say about this is that there are some really good ideas in web tech, and we've seen some really good ideas proved out with web tech. But I don't think the implementation's quite there. I think we can do better, right? I believe that there's a future where we can have awesome tooling, declarative languages, super fast turnaround without this kind of baggage. So that's why I'm excited about React. And I know that I just said there's some gotchas with JavaScript, and now I'm saying let's use JavaScript. That's fine. React is maybe not the thing of the future, but I think at the very least it has changed the way that I think about user interface programming. And I think they've done some really good things to take these good features and leave the baggage behind. So in a few quick bullets, React is cross-platform. It can run anywhere. Anywhere there's a JavaScript interpreter, you can run React, at least the core library, and we'll get into a separation in a bit. It's easy. The developer tooling is ridiculous. It is super fast, and it builds on top of the developer tooling that's already there for JavaScript. And then it's declarative, and this is we've already seen this proved out in HTML and CSS, I would argue, and React gets that and builds upon it. But I want to pause here to speak to C++ developers. So maybe you're in the audience thinking hey, I would never touch HTML or CSS or JavaScript anyway. I like my C++. And that's cool, but in my experience and the time that I've spent writing C++ UIs and trying to understand the best practices, I feel we concern ourselves a lot with how the UI should function, how to get from idea to reality, and far too little with what the UI is. Here in this example, I don't care what has to go on to get this onto the screen. That's my UI. And React is functional. And what that means is that you get to write your application one time as a pure function of the application state. And you never have to worry about how to get from one state to the next. So if my limiter is showing, it looks like this. If my limiter is enabled, it looks like this. If it's disabled, it looks like this. That's it. When the application state change, React will take care of it for me. OK, so I want to go briefly into how React works, and hopefully by the end of this, you will understand exactly what Blueprint is, and there will be not that much left to explain, actually. OK, so when you write code in React, you're actually describing your user interface as this kind of virtual description of what the UI should be. And so React takes this and turns it into a virtual tree that represents your DOM, or your application. So in this contrived example, maybe that root node is like your root container, and then we have a footer and a slider and a header that are children of that, and then we have a logo and a product logo and a preset switcher underneath the header. And so React creates this tree and hangs onto it, and then whenever something changes in your application state, React runs the same like pure function that you wrote again, comes up with a new tree. And so now React has this old and the new, and it'll perform this diff to figure out the minimum set of changes that we actually have to do to get from the old tree to the new tree. And then it will call a couple of methods on the kind of underlying renderer layer to actually get us there. So this separation is what differentiates React from the renderer. And so this renderer is this kind of like agnostic layer that does the actual work. And the renderer has this interface that looks something like this, right? Like, we needed to know how to create instances of the UI. We need to know how to like construct the tree, set some properties. And so when React was first introduced, we implemented that API with an API that looks like this. And this is the Web DOM API, right? And so we had React and React DOM. And initially, this was React, all one. But shortly after this, we kind of like understood the difference between, or this separation point. And then 2 years later, React introduced this, right? This is the same API implemented via UI view. And if you saw Tom's talk earlier, like he had this great slide that showed kind of the difference from starting in React and getting to native. And this right here is that bridge. And so this looks kind of familiar, right? Like we could do the same thing with JUCE components. And it's the same, can fulfill the same API with a very familiar JUCE component API. So that's it. So that is Blueprint, like in 10 minutes. And basically, in summary, what Blueprint is, and then I'm going to like show you some more interesting details. But it is just a React renderer implementation. So it is a lot like React Native. It is a lot like React DOM, but it is built on JUCE. And why did I want to do this? Because I wanted to use React, but I wanted to use JUCE, and I wanted to be able to ship to plugins, but also ship to iOS standalone, but also ship maybe to desktop standalone. And JUCE gives me all of that for free. OK, so how is Blueprint written? So it's really just some glue code. I've got JUCE. I run the JavaScript inside of duct tape, which is an embeddable JavaScript interpreter. And then I'm using Yoga, which is a Flexbox implementation, also from Facebook, used in React Native itself. So the piece that I haven't really touched on yet is layout. This is kind of the other thing that Blueprint will do for you. So during this reconciliation stage where we take two trees, diff them, and then figure out how to get from one to the next, the reconciler is this kind of like process underneath React that actually like hits the renderer API. And so that reconciler will issue a bunch of set property calls here. And so if you can see in this example, I'm kind of unpacking these three properties, flex, justify content, align items, onto the view element. And so under the hood, this is going to create a view instance, set a bunch of properties, add it to my root level component, and then we're rendered. And so you can see these properties here are Flexbox properties. I can kind of assign them to the node, and then when we've finished a batch of updates, I can just rerun the whole layout step. And so the way Yoga works basically is you construct these nodes, you give them the properties, and then you can just run this big tick function that will more or less create a bunch of rectangles for you, and then you just set bounds with those rectangles a bunch of times, and we've laid out your app. So, another thing here is that we can run this same step during the resized call in a JUCE component, right? Because the properties of the application haven't changed, we just have new bounds. But we already know all of the Flexbox properties, so we can just recompute without ever having to touch JavaScript again. OK, so one of the core ideas in building Blueprint was that I wanted this to be really, really flexible. And one of the things that I've done is made it so you can use basically as much or as little React as you want. So what I'm showing here in this slide is kind of like how to mount React into your application. So we have this Blueprint React application root, and this is kind of the entry point into using Blueprint. This is both like where React will take over and where we'll actually run the JavaScript. And this thing is just a JUCE component, so you can use it just like a JUCE slider or whatever you want, which means all you have to do is like make it, add and make visible, set bounds, and then React will just take over wherever we started there. So that means, for example, that if you want your entire plugin UI to be React, which that's what I was doing in Remnant, just do that at the top of your plugin editor. Or maybe you want to do like just your preset browser in React. Okay, we'll just add it like wherever your preset browser goes. The other thing that I wanted to do was like really tightly integrate with the JUCE component ecosystem. So I have some old plugins, I have some like spectrograms and oscilloscopes and whatever that I've written as JUCE components with paint routines and resize routines, and I want all that stuff. And so part of working with Blueprint is giving you the like direct access, like that same familiar API. So we have this register view type method, and this basically like tells React, like, hey, when I have open bracket, spectrogram, close bracket, this is what I want to do. This is a factory function. We create, you can see the make unique on my custom spectrogram, and then we assign a shadow view, which is kind of like how we deal with layout, but we don't need to get too far into that. The my custom spectrogram, all we have to do is derive from the like core view in Blueprint, and do whatever we want. And the Blueprint view is actually also just a JUCE component with a couple extra methods for the reconciler work. But that means that if you want to make a custom spectrogram, just derive from the view, implement a paint method, and then you can just tell React, like, hey, let's use this guy. And that has been really, really cool and really helpful for me trying to build, fast, native rendering code. I can still just run all of the JUCE graphics routines that I want, and React doesn't have to get involved there, right? Okay, so why JUCE? Like, why didn't I use React Native, for example? Well, for one, I want to make plugins, as I mentioned earlier, and that gets really tricky with React Native because React Native specifically like builds down to UI view and Android view. And I have gotten really used to, I guess, or like I really enjoy the fact that with JUCE, when I write my application, the exporters are incredibly easy, right? I just like check a box that says I want to go to Android, and then I hit go, and it works. And I want that. So I get to, like, using JUCE, I get to capture all of the existing cross-platform benefits of JUCE, which means rendering, exporters. So if I write a paint routine for my spectrogram, I can ship it to any platform without having to worry about it. We also get tight integration with the audio processing, and as JUCE grows, Blueprint grows. Future developments. So this is a brand new library. I'm very excited to share it. It is not well documented. I'm working on it. Stability and performance, I think we're coming close to like a first kind of stable API release. And so far, the performance is actually really, really, really exciting. But there's a couple like low-hanging fruit there that I'm going to work on. And then extensibility. So this thing about the fact that I'm working at the JUCE component layer behind the renderer means that I can kind of dynamically swap back there whatever I want to do. So for example, if I'm on iOS, I can render a JUCE component, or I can render a UI view for you, and we can get down to sort of like native widgets that have accessibility. And similarly, like if I want to, if I'm on Android, I can render that way. If I want native desktop widgets, I can render that way. And especially wherever JUCE makes affordances for these things, it will be super easy for Blueprint to take advantage of it. And then the next thing I really want to do is first-class paint support. So basically, I want to polyfill the JavaScript Canvas API for drawing from the React layer. OK, so running quickly out of time, I'm going to switch here to a demo, which means I need to mirror. OK, what are we looking at? Sweet. OK, so this is the gain example plugin in Blueprint. If you download it and build it, it will look like this. And what I want to show you here is, on the left, we have the plugin. This is running in JUCE's standalone plugin. Should be pretty familiar. And then on the right, we have almost all of the UI code for this plugin. Is that text OK? Can we read it all right? Bigger? Is that better? OK. OK, so first thing to note, because this is Flexbox, this thing is like resizable for free, right? And you'll notice that that center container resizes up to a limit because I just wanted to do it that way to demonstrate. And one of the things that I'm really excited about is that because this is just JavaScript, we can do hot reloading like trivially, right? So I changed the background color of my content. Boom, it just shows up. I didn't have to touch anything. And you'll see this is the content container centering itself. Now it's shrinking. So one thing to note here, too, is, OK, I'm changing the slider. I set it to -7. Now I'm coming back here. I don't like that pink. I want to get rid of it. So the slider maintains its state, right? And the important piece here is that the state is actually held in the plugin processor with the audio processor value tree state. This is totally familiar. This is how we've been doing JUCE plugins since JUCE 5 or whatever. But I get all of, like, I can integrate that with the hot reloading for free. So similar hot reloading, like, suppose I make a mistake. We'll just tell you about the mistake. Like, we don't have to run a compile loop. We don't have to do anything. We can just say, like, hey, man, you tried to use something that doesn't, you hit an error. You should fix that. So I go fix my error. OK, yeah, right. And boom, we're like right back. My state is still there even. OK, I have like 30 seconds. What if I want to like figure out what my UI should look like? Maybe I'll use 2 sliders. Oh, boom, I don't really like that. Maybe I'm going to put them in a live coding. Love it. OK, maybe I want them to stack as a row. So put them in a view. Did I write that right? I think I wrote that right. Did I mess it up? One more try. All right, I don't know what that is, but that's how live demos go, right? But I think, it's just choking. That's what's happening here. Yeah, that's what I get for trying to run Xcode in the background without showing you guys. OK, so let's just kind of skip that part. Oh, that one. That's the one. OK, that error showed up last night. I don't know what's up with it. But I recorded this when it was still working. Hit me. Is that running? The recording is quick, so I feel confident about this. Maybe I have to do something special to get Xcode to play the video. All right. It is going. Oh, OK. It just doesn't, it's not going for me. So just watch that for a minute. What I wanted to show was that as I'm like figuring out what my UI should be, right, like I have this incredibly fast turnaround. So at that point where I was trying to put the sliders together and stack them horizontally, all I have to do is throw them in another view because, similar to web tech, like we can have default Flexbox properties and things will stack and align without me having to like think about it, right? I don't have to worry about lifetime ownership, any of these things. It's just fast. It's just there. It's just easy. So is that still going or are we done? And so there's this piece in here that I think is interesting, which is that because I have the same param ID on the same sliders, they automatically mirror each other. They link. And I feel like that's been kind of a hard thing to do in JUCE directly. But here it's trivial. And so I take away the other param ID, and one of the sliders becomes defunct, but the label still updates because I have the same param ID on that label. It's really exciting. So, OK, wrapping up here. The project is on there. I will put the slides up, but you can check it out right now. I'm working on documentation. I'll do that quickly. And I want to plug the audio programmer channel. So like that Discord is a chat server. I hang out in there all the time. Come in, chat with me. If you're hitting an issue, I'll just help you out. All right, thank you so much.
Thanks, Nick. This was very cool. Unfortunately, we ran out of time, and there are demo sessions in the lunch area. But feel free to contact Nick around the lunch area and ask him questions. Thanks.
Thanks.